Hello and welcome to In Simple Terms with Satish. You put yesterday's rice, pasta or curry into the microwave. 2 minutes later, the bowl is hot, the edge is steaming and the center is still cold. That is not random. That is the microwave telling you exactly how it works. Today, let's understand how microwaves heat food. A microwave is not a tiny oven with invisible fire. It is closer to an energy transmitter inside a shielded metal room. Instead of heating air first, it sends electromagnetic waves into the chamber and lets food absorb energy directly. Inside the oven is a device called a magnetron. It converts electrical energy into microwaves, usually around 2.45 GHz in a household oven. Those waves enter through a waveguide. The metal walls reflect them, so energy bounces around the cavity instead of escaping. Glass, paper, ceramic, and many plastics mostly pass microwaves through. Metal reflects them, food absorbs them. The main heating mechanism is called dielectric heating. Food contains water and water molecules are polar. That means one side of the molecule is slightly positive and the other side is slightly negative. The microwave field keeps changing direction, so those molecules keep trying to turn and line up. They cannot follow perfectly. They lag, twist, bump into neighbors, and lose energy as heat. This does not mean the food becomes radioactive. It means electromagnetic energy became heat. Water is the star, but not the only actor. Fats, sugars, salts, thickness, and structure also change absorption. That is why soup, bread, cheese, frozen vegetables, and meat do not behave the same way. Now return to the cold center. Microwaves do not magically cook food from the inside out. They penetrate some distance, but not infinitely. In thick or frozen food, the outer regions can absorb energy first. Then ordinary heat conduction has to carry warmth inward. That is why a dense frozen block can have hot edges and an icy middle. The microwave did not fail. Physics is asking for more time. This is also why standing time is not a polite suggestion. When the timer ends, temperature is still moving from hotter regions to colder regions. Letting food sit for a minute gives conduction time to finish what the microwave started. The oven itself also creates hot spots and cold spots. Microwaves bouncing inside a metal cavity form field patterns. Some places receive more energy, some receive less. The turntable is not decoration. It moves the food through different parts of the field, averaging out the unevenness. Some ovens also use a hidden stirrer that changes the wave pattern. And the bowl? A microwave-safe bowl mostly lets waves pass through. If it becomes hot, that is often because the hot food heated the bowl. Some materials absorb microwave energy too, which is why microwave-safe containers matter. Power settings are another hidden detail. In many older microwaves, 50% power often means full power turning on and off in bursts, not a half-strength magnetron. Newer inverter designs can deliver smoother, lower power for gentler heating and defrosting. So defrost mode is not magic either. It is mostly giving heat time to move before the outside overcooks. The practical mental model is this. A microwave does not cook food evenly by default. It deposits energy where the waves and the food allow it. Then heat still has to travel. That explains stirring, rotating, covering, lower power, and waiting. It also explains why one food can be perfect while another has lava hot edges and a frozen center. The safety story is simpler than many people think. When the oven turns off, the waves stop. The metal cavity, door mesh, seals, and interlocks keep energy inside while the oven runs. In simple terms, a microwave heats food by using a changing electric field to make polar molecules, especially water, absorb energy. That energy becomes heat. But the final result depends on the whole system: magnetron, metal cavity, wave patterns, turntable, food chemistry, food shape, power timing, and heat conduction. The microwave is fast because it can put energy directly into the food. It is uneven because physics still gets a vote. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish and share this episode with one friend who likes technology. I will see you in the next episode.